Hello everyone, welcome to the course on Plan Method Standard Annotation. Today, we will learn about the plan notation for isolated foundations. First of all, let's review the contents of this lesson. It mainly includes two parts: plan notation for isolated foundations, and the interpretation of isolated foundation drawings using the plan notation. First, let's get familiar with plan notation for isolated foundations. Isolated foundations can be divided into conventional isolated foundations and socket-type isolated foundations. According to the cross-sectional shape of their foundation slabs, they can be further divided into stepped and sloped types. The annotation methods include plan annotation and cross-sectional annotation. The plan annotation method consists of centralized annotation and in situ annotation. In centralized annotation, the foundation number, vertical sectional dimensions, and reinforcement are mandatory annotation items. Elevation difference and text notes are optional annotation items. In situ annotation includes plan dimensions and other reinforcement details. Cross-sectional annotation is divided into sectional labeling and schedule labeling. In the upper right foundation plan, the upper part shows the centralized annotation, and the surrounding dimensions are the in situ annotations. In the lower left plan, the centralized annotation includes three items: number, dimensions, and reinforcement. Now, let's go through the key content of this lesson, the plan annotation of isolated foundations. First, let's learn about centralized annotation. First point, numbering. This is a mandatory annotation item. It consists of a code and a serial number. Isolated foundations are classified into stepped and sloped types, based on the cross-sectional shape of the foundation slabs. Thus, their codes are also different. DJ is the uppercase initials of the pinyin for conventional isolated foundation. The subscript J represents a stepped type. Other types follow similar coding rules. The four diagrams below respectively represent the cross-sectional shapes of foundation slabs. As we can see, their common feature is symmetry. The left diagram shows a conventional isolated foundation with a stepped foundation slab, so its code is DJ sub J. The right diagram shows a conventional isolated foundation with a sloped foundation slab, so its code is DJ sub P. Second point, vertical cross-sectional dimensions. This is a mandatory annotation item. First, let's look at the conventional isolated foundations. If the foundation slab is stepped, it can be represented by a set of numbers separated by slashes. For example, h1/h2/hn. These respectively represent the heights of each step from bottom to top. For example, in a stepped conventional isolated foundation, if each step height from bottom to top is 200 mm, then the total thickness of the foundation slab is h1 plus h2 plus h3 equals 600 mm. For conventional isolated foundations, the sloped cross-sectional dimensions are the same as for stepped sections. They are all represented by numbers separated by slashes. For example, h1/h2 respectively represent the heights of each step from bottom to top. This diagram shows the schematic of stepped and sloped conventional isolated foundations. Let's take a look. First, when the vertical dimensions of the stepped conventional isolated foundation, DJ sub J1, are annotated as 400/300/300, it means h1 equals 400 mm, h2 equals 300 mm, h3 equals 300 mm. And the total thickness of the foundation slab is 1000 mm. Second, when the vertical dimensions of the sloped conventional isolated foundation, DJ sub P2, are annotated as 400/300, it means h1 equals 400 mm, h2 equals 300 mm, and the total thickness of the foundation slab is 700 mm. 2 points to note. 1. All cross-sectional dimensions are measured from bottom to top. 2. The total thickness of the foundation slab is the sum of all step heights. Third, reinforcement. This is a mandatory annotation item. Various reinforcement annotation situations are shown in the table. There are three types of reinforcement for conventional isolated foundations, not necessarily all appearing simultaneously. What we need to note is that each type of reinforcement is represented by different characters and applies to different scopes. It is important to understand these distinctions. First, B represents the bottom reinforcement of various isolated foundation slabs. It is divided into X-direction reinforcement, annotated with X at the beginning, and Y-direction reinforcement, annotated with Y at the beginning. When the reinforcement in both directions is the same, it is annotated with both X and Y at the beginning. As seen in the sectional details in the table, the medium thick red lines represent the reinforcement of the foundation slab, which is placed at the bottom layer. The Y-direction reinforcement is located above, and the X-direction reinforcement is below, forming a reinforcement grid. This diagram shows the reinforcement tying and formwork installation of a conventional isolated foundation slab. Second, DZ represents the vertical dimensions and reinforcement of short columns in conventional deep isolated foundations. First, annotate the longitudinal reinforcement of the short column, then the stirrups, and finally, the elevation range of the short column. The annotation format is corner reinforcement / middle reinforcement of the long side / middle reinforcement of the short side, stirrups. Elevation range of the short column. When the horizontal cross-section of the short column is square, it is annotated as corner reinforcement / middle reinforcement of the X side / middle reinforcement of the Y side, stirrups. Elevation range of the short column. Let's take an example. When the reinforcement of a short column is annotated as DZ, for C25 C18/5 C18. A10 at 100, -2.5 to -0.05. It means the short column of the isolated foundation is placed within the height range from -2.5 to -0.05. It is equipped with vertical longitudinal reinforcement of HRB 400 grade and stirrups of HPB 300 grade. The vertical longitudinal reinforcement consists of 4 C20 corner reinforcement, 5 C18 middle reinforcement on the X side, and 5 C18 middle reinforcement on the Y side. The diameter of the stirrups is 10 mm, with a spacing of 100 mm. Due to the increased height of each step in the cross-sectional dimensions of the foundation slab, the total thickness of the foundation slab increases, so short reinforcing columns need to be added to enhance the structural resistance of the foundation slab. Third, T represents the top reinforcement arranged between columns in double column isolated foundations. Reinforcement annotation rules. First, annotate the tensile reinforcement, then the distribution reinforcement. An example is given on the right. The top of the isolated foundation is equipped with longitudinal tensile reinforcement of HRB 400 grade, with a diameter of 16 mm and 7 bars arranged. The spacing is 150 mm, and the distribution reinforcement is HRB 400 grade, with a diameter of 10 mm and a spacing of 200 mm. As shown in the diagram, when the conventional isolated foundation consists of multiple columns, the bottom reinforcement of the foundation slab represented by the red solid line reinforcement mesh can no longer meet the requirements. Thus, top reinforcement needs to be added, represented by the green solid line mesh. Fourth point, elevation and text annotations. This is an optional annotation item. When the bottom elevation of the isolated foundation is different from the reference bottom elevation of the foundation, the bottom elevation of the isolated foundation should be directly annotated in parentheses. When there are special design requirements for the isolated foundation, necessary textual notes should be added. For example, whether the length of the foundation slab reinforcement is shortened, it can be noted in this item. The other part of plan annotation is in situ annotation. For in situ annotation of symmetric stepped cross-section conventional isolated foundations, both X and Y dimensions are annotated from both sides towards the center. For in situ annotation of asymmetric stepped cross-section conventional isolated foundations, X is annotated from left to right, and Y is annotated from bottom to top. For in situ annotation of symmetric sloped cross-section conventional isolated foundations, both X and Y dimensions are annotated from both sides towards the center. For in situ annotation of asymmetric sloped cross-section conventional isolated foundations, X is annotated from left to right, and Y is annotated from bottom to top. This lesson mainly covers 1. Classification of isolated foundations. 2. Plan annotation for conventional isolated foundations. 3. Plan dimensions in situ annotation. The key focus is the plan annotation for isolated foundations.